Hello everyone. Today I am about to discuss a topic on roots of complex numbers. In our lower standards, we have already learned how to find the roots of algebraic equations of the form ax square plus bx plus c. We find its roots by either splitting of middle term or by discriminant method, that is by the formula x equal to minus b plus or minus under root of b square minus 4ac upon 2a. Using either of the method, we used to find the roots of any algebraic or quadratic equations. So now we will learn how to find the roots of complex numbers. Here we use De Moivre's theorem to find the nth roots of complex numbers. Now see, what is De Moivre's theorem? De Moivre's theorem states that cos theta plus I sin theta raised to 1 by n, that is nth root of complex number, is equal to cos 2k pi plus theta upon n plus I sin 2k pi plus theta upon n. Now we substitute n equal to 0, 1, 2 up to n minus 1, we get n distinct values of cos theta plus I sin theta raised to 1 upon n. Thus, for each z equal to r into cos theta plus I sin theta, which is not equal to 0, there is exactly n values of nth root of z. That is, z raised to 1 by n is equal to r raised to 1 by n cos 2k pi plus theta upon n plus I sin 2k pi plus theta upon n. We name it as equation 1. Now let us use this formula and De Moivre's theorem to find the distinct values and try to plot it. Our first question is, find the distinct values of 1 plus I raised to 1 by 3 and plot. We have to plot it roughly. We don't need the exact values. Now, here we consider this 1 plus I equal to z. We name it as z since it is a complex number. First, we use this to find r and theta. We have already learned in basic of complex number. In my previous videos, I have discussed it. R equal to under root of x square plus y square is equal to 1 square plus 1 square. We know that real part here is x equal to 1 and imaginary part is y equal to 1. So we substitute these values, we get r equal to root 2. Now we find theta. Formula is tan inverse y by x. Since x and y both are positive, it will be in first quadrant. So we get tan inverse y by x equal to tan inverse 1 by 1, that is tan inverse 1, that is pi by 4. So we have named this 1 plus I as z, so it can be written as r cos theta plus I sin theta. Now the value of r is root 2, theta is pi by 4. We have substituted this in the equation. Now we have to find 1/3 root. 1 by 3 it is given. So we take here both the sides, 1 by 3 power, here also and here also. Now using equation 1, or we can say De Moivre's formula, we can name it. we first separate 1 by 3 powers here. So this will become root 2 raised to 1 by 3, and according to de Moivre's formula, this 1 by 3 will go in the denominator of cos and sine angles. So we can write it as cos 1 by 3 2k pi plus pi by 4 plus I sine 1 by 3 2k pi plus pi by 4. This is the use of de Moivre's formula. Now, since the power is 1 by 3, we have to take n minus 1 values starting from 0. So, first we'll put k equal to 0, k equal to 1 and k equal to 2 in this equation of k. So, we get this root of 2 1 by 3 can be written as 2 raised to 1 by 6. Now, we put k is equal to 0 here. We get 1 by 3 pi by 4, since this term will become 0, plus I sine 1 by 3, this again k equal to 0, this term will become 0. So, we get sine 1 by 3 pi by 4. Simplifying this little bit more, we get cos pi by 12 plus I sine pi by 12. Now see, here I have written below 15 degree. This I have written so that we can plot it easily. We can know the approximate values and it will be easy to plot it roughly. Okay, so this will be approximately 15 degree. Now we put k is equal to 1 in that equation. After putting k is equal to 1, we get here 2 raised to 1 by 6, that will be as it is in the whole example. Cos 1 by 3, we kept k equal to 1, so we get here 2 pi plus 5 pi by 4 plus I sine 1 by 3 2 pi plus pi by 4. Taking LCM and simplifying the angle of sine and cos, we get here 9 pi by 12 plus I sine 9 pi by 12. Again, 9 pi by 12 is approximately 135 degree. Okay, now we put again k equal to 2. Substituting k equal to 2, we get 2 raised to 1 by 6 cos 1 by 3 4 pi by 4 plus I sine 4 pi plus pi by 4. Again, substituting this angle part, we get here cos 17 pi by 12 plus I sine 17 pi by 12. Again, 17 pi by 12 is approximately 255. Okay, now from these values we got 3 values and the power of 1 plus I is 1 by 3. So we will get 3 values z0, z1 and z2. That will try to plot it. As we know, this is x-axis and this is y-axis. Our first part was 15 degree. So we plot here, approximate will take, there is no need for exact value. So we did here z0. Our next portion was 135 degree. So we plotted approximately 135 degree as z1 and our last one was 255 degree, which was our z3. Okay, so in this way we can find the roots of complex number. Specifically, we can say that nth root of complex number. Okay, now we will see with one more example. Some of the questions can also be asked like this. Find the fifth roots of unity. Find the fifth roots of unity. Fifth root means 1 raised to 1 by 5. We can say, see, I have written here 1 raised to 1 by 5. That is called fifth root of unity. So I can write here as x raised to 5 equal to 1. Again 1 can be written as 1 plus 0i. This is for our convenience. First we have to find again r and theta. R is under root of x square plus y square. Here our x is 1 and y is 0. So again root of 1 square plus 0 square, that is root 1, which is equal to 1. Again we find theta now. So we get tan inverse y by x. Okay, according to our formula of argument. So we get tan inverse 0 by 1. Tan inverse 0 is 0. So we get the value of theta as 0. As we done in our first example, we can write here 1 as r cos theta plus I sin theta. Okay, value of r is 1, theta is 0. Now taking fifth root both the sides, we get 1 raised to 1 by 5 equal to 1 plus 1 into cos 0 plus I sin 0 raised to 1 by 5. Okay, now again using de Moivre's rule, this n will go, n is 5, that will go to the denominator of the angle of cos and sin. So we get here cos 2k pi plus 0. Formula was 2k pi plus theta, okay, upon n. So n is 5. Similarly for the sin term we can write I sin 2k pi plus 0 upon 5. This can be written as cos 2k pi by 5 plus I sin 2k pi by 5. We have to take values of k up to n minus 1 term. So we will go for k equal to 0, k equal to 1, k equal to 2, k equal to 3 and k equal to 4. We will put these values of k in this equation. First we put k equal to 0. So we get z0 equal to, this term will become 0, this term will become 0. So we can write cos 0 plus I sin 0. Now we put k equal to 1. So putting k equal to 1, we get cos 2 pi by 5 plus I sin 2 pi by 5. Again 2 pi by 5 is approximately 72 degree. We can find by taking pi equal to 180. Okay. Now we put k equal to 2. Substituting k equal to 2, we get z2 equal to cos 4 pi by 5 plus I sin 4 pi by 5. Again 4 pi by 5 is approximately 144 degree. Now we substitute k equal to 3. So z3 equal to cos 6 pi by 5 plus I sin 6 pi by 5. 6 pi by 5 is approximately 216 degree. Now last we put k equal to 4. Putting k equal to 4, we get z4 equal to cos 8 pi by 5 plus I sin 8 pi by 5. Again 8 pi by 5 is approximately 288 degree. Okay. If asked to plot, we can plot in this way. Our first angle was z0. That was for cos 0. We can put here. Okay. Since this is 0 degree. Z1 was approximate 72. So it is near about here, this one is 72 degree. Similarly, we can plot roughly for Z2, Z3 and Z4. This is our required plotting and required roots of the given complex number. So friends, here we have find the nth root of complex number. Now we can also find the roots of quadratic equation like az square plus bz plus c. equal to 0. For such type of equation, using discriminant method, we can find the values of z. Okay, so in my next video of roots of complex number 2, we will learn how to find the roots of quadratic complex equation, that is az square plus bz plus c equal to 0. Okay, I hope you are clear with this topic. Thank you.